Hello friends. Today I am going to discuss briefly about MXenes and their stability in PDLC-based smart windows. The MXenes are two-dimensional layered carbide and nitrides of transition metal elements like titanium, etc. And these are obtained by the selective etching of the MX phases. And what are these MX phases? MX phases have formula Mn+1 where M is an early transition metal, A is an element from group 13 or 14, and in most of the cases it is aluminium, X is C and or N, and N equals 1, 2, or 3. MXenes were discovered in 2011 by Gagazzi and Associates, and till date more than 100 MXenes have been predicted. And among these MXenes, T3C2TX is the most popular one. Why these MXenes are important? These MXenes have high conductivity around 20,000 Siemens per centimeter. And these MXenes are highly hydrophilic in nature because they have OH group and oxygen-terminated groups on their surface. The single layer of MXenes is highly transparent, having a transparency of more than 97%. They have high surface area, and they have promising electrochemical properties. But one major problem with the MXenes is that these are highly oxidized. Under ambient conditions, MXenes are easily oxidized. How to obtain the MXenes? The MXenes are obtained by the etching of the MX phases by removing the A layer by selective etching using the hydrofluoric acid or by combinations of HCl and LiF. After acidic etching, the resultant mixture is washed multiple times till the pH of the solution becomes around 6 to 7. After etching, the MXenes can be exfoliated by ultrasonic treatment or by simple rigorous shaking. Then the stacked layers of the MXene can be exfoliated into single layers. You can see the FESM images of the MX phase before etching and after etching with acids. The etched accordion-like structures can be seen. You can see some differences while etching with HF or LiF/HCl etchant. There are many ways to prevent the oxidation of the MXenes, but we can prevent MXenes oxidation by using them as conductive layer electrodes for PDLC-based smart windows. The smart window was fabricated using polymer dispersed liquid crystals. The PDLC mixture was prepared by mixing commercial polymer Nova 65 and liquid crystals in 1:1 ratio. And this mixture was sandwiched between the MXenes coated PET film to make flexible electrodes. After sandwiching the mixture between the MXenes electrodes, the mixture was cured under UV light for some time. After curing, the polymer becomes solid. It forms a protective layer around MXenes. Also, the liquid crystals droplets are encapsulated inside that cured polymer. These liquid crystal droplets are mostly spherical and are randomly oriented, so no light is allowed to pass through them and hence the opaque state is observed. But as we apply the voltage, then these liquid crystal droplets are aligned in the direction of the applied electric field and the light can easily pass through the smart window, giving rise to an on state. In this way, smart windows can be turned on and off by applying the AC voltages. Let us summarize it quickly. The MXenes can be exfoliated into single layers, and it can be dispersed in different solvents. MXenes are easily oxidized in DI water, however, if these are stored in the water, but they are stable if they are dissolved in some organic solvents like IPA, acetone, ethanol. We can also prevent the oxidation of the MXenes by storing in sodium L-ascorbate solution. The oxidation occurs even in dried form, but the oxidation rate is relatively slow. If we store these films in a vacuum or if we passivate the MXenes by polymers, we can preserve their oxidation. The best way to protect the MXenes is to use MXenes in applications such as in PDLC-based smart windows. The polymer in the smart window can preserve the MXenes, while the MXenes can also work as electrodes. If you know any other application where we can use the MXene while protecting them, do share that application in comment box. If you want to know more about MXene stability studies, you can see our recent publications. Application-dependent stability of T3C2TX MXene in PDLC-based smart windows. Long-term stability studies and applications of T3C2TX MXene. Application of titanium carbide MXene-based transparent conducting electrodes in flexible smart windows. Thanks for watching.